we're going to take a few minutes to look at star motions from different locations on the Earth. Right now I have Stellarium and it's set to Michigan. And we're just going to take a look at how stars move from the perspective of us here in Michigan. So I'm going to ask you to do the same thing for different locations on Earth, and I just want to illustrate how you should describe this motion, because it's kind of confusing describing all this weird motions in the sky. So let's just take a look. I'm going to set time going. I'm going to turn off the atmosphere so that we just keep seeing the stars. And I'm really only interested in the stars here, so I'm going to just set time going at a nice clip so we can see the stars moving. And what I want to do is describe this motion by looking all four of the cardinal directions. Okay, so let's start in the east. It's a good idea to usually start in the east. So what's happening here? As time's going forward, the stars are rising. So that's the first way we could describe this motion. The stars are rising in the east. But more than that, notice how they're going up and kind of to the right. Now I would describe that using the words of altitude and azimuth. So since they're going up, we'd say that the altitude is increasing. Alright? And since they're going to the right, so north is on this side, east, and then south over here, that means the azimuth is also increasing. So if I were writing this down, I would say, from Michigan, looking east, the altitude is increasing and the azimuth is increasing. And I might even write in parentheses, up and to the right. Okay, and now if I look south, what I see here is that the stars are generally kind of going in a little bit of like a circle, you could say, right? Like they're kind of rising and going to the right and then falling again. And whenever we have motion that's kind of like a circle, it's helpful to describe it using calling it like clockwise or counterclockwise. So I would say it's rising over here, setting over here. It looks to me like that's clockwise motion. So one way to say this would be the stars appear to move in a clockwise circular motion when looking south. You could also talk about it in terms of the altitude and azimuth, saying the altitude increases and then decreases while the azimuth continues to increase. Okay, now let's look to the west. When I look to the west, the stars are setting. So that's the first thing I would say. The stars appear to set in the west. So their altitude is decreasing, but they're still moving to the right. Their azimuth continues to increase the whole way along. So azimuth is increasing, altitude is decreasing, and I could say they're going down and to the right. And now when we look to the north, this is where it gets a little interesting. You'll see the stars look like they're kind of moving in a big circle, but this time I can see the whole circle, if you will. Let's follow Capella here. Right now it's going up and to the left, so this is now sort of counterclockwise, right, as it goes around. But later on, when Capella gets down further, I'll speed up time a little bit. Right now it's going to the right. So these stars are going in a complete circle, and I can kind of tell that the center of the circle is this star right here. Let me just kind of speed up time a little bit. You can see it even more clearly. This star right in the middle, which is Polaris, that's the North Star. All the stars appear to be kind of spinning around it. The North Star, that's the North Celestial Pole, right? That's the extension of Earth's North Pole out into space. And so as Earth rotates, that point appears fixed, and all the stars appear to rotate around it. So the way I would describe this motion is I would say that the stars are moving counterclockwise around the star Polaris. Now I could even, in Stellarium, I can even zoom out and look at the whole sky. So I'm going to kind of orient myself to the south here, and we can see the whole sky going by. But that's just kind of confusing. It looks cool though. I just want to show that to you. Alright, let's understand this motion in a different perspective. So we've seen it here sort of like the observer on the Earth. I want to show it to you a little different way. Here's sort of the outside perspective on the celestial sphere. And I'm going to add a couple stars. Alright, and our location here, our latitude, is going to be set to Michigan, so about 43. Okay? And I'm going to set this moving, and we're going to see some star trails. Now, as we look at this, we're going to see the same kind of thing we saw before, right? If I look to the east, I'm looking kind of through the celestial sphere at the east. The stars are rising and up to the right. The south, they're kind of increasing then decreasing while still moving to the right. And in the west, their altitude's decreasing while they're still moving to the right. And then we look north, and we see there's a circumpolar star. We call that a circumpolar star because it keeps going around and around. It never sets. That's why it's marked in blue. Right? So this circumpolar star is going around the North Celestial Pole, and see, it's moving counterclockwise. Now, all of this motion can be understood by thinking that this entire celestial sphere, let's start from scratch one more time, reset the star trails. This entire celestial sphere is just rotating around us, right? And because this whole celestial sphere is rotating, we see these motions when we're looking east, south, west, and north. But it's all understood from this bulk motion, which is really the Earth rotating, but this bulk motion of the celestial sphere. Now, what's cool is this looks different when you're in different places on the Earth, and so this can actually help us find our location on the Earth. So let me just remove all these stars and maybe add one or two back, and I'm going to change our location to the North Pole. Okay, so now this dude's standing on the North Pole. I'm going to add a bunch of stars, and now let's think about if this whole celestial sphere is rotating along the axis from the North Celestial Pole to South Celestial Pole. The whole thing's spinning. Let's see what that's going to look like. So to an observer on the North Pole, we see that all the stars just appear to be going in a big circle. They don't rise or set. They're just moving, increasing azimuth all the way around. Their altitude doesn't even change, right? Which makes sense. If this whole celestial sphere is rotating, that would kind of make sense. Let's take a look and see what that would look like in Stellarium. So I'm going to change my observer location to the North Pole, at least as close as I can get to it, way up here. There we go. All right, and I'm going to make sure the atmosphere is turned off. And now let's just look at what happens to the stars as they move. So now I'm going to look east again. Remember before in Michigan we saw the stars. Oh wait, where's east? Everything is south. Right, when you're on the North Pole, every direction is south, right? Because you can't go any further north. Okay, but let's look at the star motion, right? As I make it go, notice the stars are not rising or setting. The whole way around, they're just spinning, right? Because you're on the top of the Earth, and the Earth is spinning, so all the stars appear to be spinning. If we take this view all the way up at the sky, right? And now check it out. The one star that's not moving is still Polaris. All the stars are rotating around Polaris, and they're still going counterclockwise. Pretty cool. Okay, so how would I describe this motion? I would say the stars are constantly increasing azimuth, and their altitude never changes. Or another way I could say it is they're moving counterclockwise around Polaris, which is located at the zenith, straight overhead. Okay, let's take a look at one other location, and that would be the equator. Let's look at that from our little animation here. I'm going to reset the star trails, and I'm going to move our latitude to 0, because that's the equator. Or close to 0, okay? So now I've tilted the whole celestial sphere. Now the North Celestial Pole is right here on my horizon, and if the whole sphere rotates, what do you expect this motion is going to look like? Let's check it out. Okay, the whole sphere is rotating, but now our perspective has changed because we're at a different location on Earth, and the stars appear to be rising straight up in the east and setting straight down in the west. And when I look to the south, they're going in a circle around the horizon, a point on the horizon, and the same is true on the north. Right, but again, this whole thing can be understood by thinking about the big celestial sphere that's rotating. All that's changing is our perspective as we move on the Earth. Let's just look at that real quick from Stellarium. I'm going to go to the equator, at least as close to it as I can get. My latitude is going to be 0. Boom. Well, that didn't work. Let's try that again. Latitude, pretty close. There, okay. So now I got my directions again. I'm going to look to the east, and let's see what happens as I go forward in time. There the stars are. They're going straight up in the sky. Right? So their altitude is just increasing. Their azimuth isn't changing at all. Altitude is increasing. If I look to the south, okay, I would say they're moving clockwise. Again, right? Altitude increases, azimuth increases. And then if I look towards the west, again, their azimuth hardly is changing at all. It's just decreasing altitude sets in the west. Again, in the north, they're moving counterclockwise, and now I can't even see Polaris. It's right on my horizon. Okay, so now we've seen how stars move in many different places on the Earth, but it can all be understood by the same motion of the celestial sphere rotating around the Earth.